Okay. This is notes on the chain rule. The chain rule is a process of differentiation that is very, very common in calculus, and you really have to have a solid understanding of it. So I'm going to try really hard to explain it well. If you don't like the way I explain it, find somebody else to explain it, and we will practice it a lot in class. Basically, if you have a function h of x that is the composition of two functions f of g of x, the derivative of h of x, or h prime of x, is the derivative of f. So you take the derivative of the outside function, but leave the inside function alone, and then multiply by the derivative of the inside function. So let's take a look here. Hopefully you can see that this is a composition of two functions. 3x plus 2 got put into x cubed. Okay, so if we're going to take the derivative h prime of x, we're going to take the derivative of the outside, which f prime of x would be 3x squared. But remember, we said take the derivative and leave the inside alone. So we're going to leave the 3x plus 2 and just make that, this is kind of like the x, times the derivative of the inside, which is just 3. So h prime of x here would be 9 times 3x plus 2 squared. Personally, I think this is all a little bit confusing. I like to say take the derivative of the outside, leave the inside alone, times the derivative of the inside. So here, my bigger function, if this is h of x, the big thing is the square root of x, right? What got put into the square root of x? Well, this 13x squared business got put into the square root of x. So the derivative of the outside would be the derivative of the square root of x. So I'm going to write this like 13x squared minus 5x plus 8. If I had given you this problem last week, you would have said, oh, the derivative is 1/2 times 13x squared minus 5x plus 8 to the negative 1/2, which is true, except now you have a function within a function, so you have to multiply by the derivative of the inside. So again, the derivative of the outside, leave the inside alone, times derivative of the inside. And you can distribute all that and do all that messiness, but this is the bottom line. This is what you have to do the chain rule. Here, the inside is this, the outside is x to the 1/3. So again, let's use proper notation here. Derivative of the outside would be 1/3 times something to the negative 2/3. So remember, 1/3 minus 1 is negative 2/3. Leave the inside alone. And then multiply by the derivative of the inside. That's a parentheses. God, I hate this. I need my software back. Negative 4 minus 5x to the negative 6. And again, that's fine for right now. None of them are going to be this gross and nasty and awful. And we don't have to do anything else with it. If we had to write an equation of a tangent line or something, then we might need to plug something in or whatever. But for all intents and purposes right now, that is a totally fine answer. Here, the outside is e to the x. The inside is this thing. So take the derivative of the outside, which is the same thing you're given, but now you have to multiply by this derivative. 10, that's a 10, it won't let me write it. Ugh. And now we're not responding. 10x minus 7. You getting it? I hope so. The chain rule is most commonly used with trig functions because usually you don't just have sine of x, you usually have sine of something. So the derivative of the outside, so the derivative of sine is cosine 5x, and then times the derivative of the inside, which is 5. So the answer to this would be 5 cosine 5x. This is where it shows up the most. Here we have product rule and chain rule. Now, hopefully you're starting to understand that product rule when a constant is in front is kind of like saying What's the derivative of 3x? Well, we don't do the product rule here, but we could. The product rule here would say first times derivative of the second. Well, what's the derivative of 1x? 1. Plus second x times derivative of the first, 0. So this is still just 3. When you have a constant times a function, you don't have to do the product rule. It's just the derivative is just the constant times the derivative of the inside. So our answer is going to be 3 times something. Now, the derivative of tangent of the square root of x is the chain rule. So the derivative of tangent is secant squared, leave the inside alone, times the derivative of the inside. So now I like to distribute these two because it comes out kind of nice. Secant squared root x times 1 over root x. Now I pray that you don't want to cancel these, because this is not secant squared times the square root of x, it's secant squared of the square root of x. So these are not the same thing. You can't cross them out. That's your final answer. 2 more. Cosine of x cubed. So the derivative of cosine is negative sine, leave the inside alone, times the derivative of the inside. And again, we would write it like this. This last one's tough. This is a double chain rule. So the innermost function, we'll call that, let's say this is f of g of p of x. So p of x is x cubed, and g of x is x squared, and f of x is cosine x. So if you put that in there, you get cosine squared of x, but cosine squared of x cubed. So the derivative of the total outside, derivative of cosine, is negative sine, and then leave the inside alone, sorry, I just realized I messed that up. What you really did was you put cosine into x squared. So we're going to take the derivative of cosine squared, which is 2 cosine x cubed to the 1, times the derivative of cosine, which is negative sine of x cubed, times 3x squared. I know that seems crazy and really hard. We'll talk about it. Put that negative out in front. Cosine x cubed sine x cubed. Don't stress about this one. Okay, we'll do a lot more of these, but basically I took the derivative of something squared, then I put the 2 out in front, left the something alone, subtracted 1 from the exponent, multiplied by the derivative of cosine, which is negative sine, but I left the x cubed alone, then multiplied by the derivative of x cubed. Okay? Just understand the chain rule is derivative of the outside, leave the inside alone, times derivative of the inside.